Up next we have Andy Payne, I believe. Is Andy here? He's on his way. Always there. Look, I thought you were bringing lots of swag then for a second, but that's...
Hi everybody, welcome. So I'm Andy Payne. I'm the Worldwide Solutions Lead here at AWS for Game Tech, and I look after something called Game Production in the Cloud, which essentially is focusing on all the game development pipelines, the tools, the tech, and the solutions that we can use in the cloud to do our development. So my background actually comes from architecture way back in the day, where if you did a render of something, it probably took you all night, and then if you came in the morning and you were lucky, it actually looked good. And then I thought to myself, gosh, there must be ways that we could do things better. So from then on, I've always thought, how do we solve problems using tools and tech to actually make things a lot better? So I moved into content creation tools in the 90s, and subsequently worked with games and film, VFX, and how they were using content creation in the early days of 3D. And then for the last 15 years, I moved into games middleware and engine technology. Anything from physics to character animation to pathfinding, visual debugging, you name it, whatever tools, were good and we could integrate into engines, made our lives a lot easier. So with all that knowledge, I kind of joined AWS and I thought, okay, how can we do some of these things in the cloud? So as I said, day to day, I look at the tech and the tools that we use and work a lot with partners to try and make that better on AWS. So today, what I'm going to do is just look at some of the industry challenges that we've had and we still face with remote development. Then I'm going to look at essentially what we call distributed development. So in other words, we're all over the place. How do we still do a development when we're distributed around the world or our countries or wherever, working from home? And then finally, just show some examples of what some of the studios are doing today on AWS in the cloud. So obviously, let's start with, our world today completely changed over the last 2 years, but we've been doing distributed development in our industry for some time. We've been collaborating with multi-studios, different studios, outsourcers, people in different locations. But obviously, the last few years, we've all done a lot more of it. And our internal infrastructure in our studios is not really geared up for everybody to be remote. And that's where the problem lies. So whether we're working in the studio, part-time or full-time, at home, part-time or full-time, we want to be able to hire people now from anywhere in the world and make sure that we can onboard them very quickly. That becomes a struggle when you have to think about then, okay, how do we get them onto our projects quickly? Provision hardware, install hardware, software, ship it to them. That's very difficult to do. We want to become a bit more agile in this new world. So I'm just going to go through a few reasons why you should build in the cloud. So I've already highlighted that, studio infrastructure is not really geared up for distributed development. It becomes a bottleneck for us to access. As individuals or as other teams, we have to access the studio. Now, one of the reasons why we have studio infrastructure is that's where we want everything to be stored. We're very protective about our IP. We want it to be secure. And it's always a worry. But the trouble is, as we develop games, we know year on year, project on project, the data sizes change, they increase, our compute requirements increase and become extreme, and so does our storage. So we're always trying to play catch up with what we have in the studio. So they do become a bottleneck. So as I said, what game production in the cloud about, or what remote game development is about, it's about how do we migrate those workloads, those development pipelines that we have in studios traditionally that we use, and leverage the cloud to be able to scale when we want to be able to onboard new hires when we want to. So the one thing that cloud does, obviously, is it doesn't limit us to a single location like a studio does. You know, it's fixed. The cloud frees us up from that. So as I mentioned, some of the things that we want to be able to do is onboard those new hires quickly, doesn't matter where they are in the world. Whether those full-time hires are going to be full-time hires or whether they're going to be contractors, you need to set them up so they get the right access to the project data that you want them to have. So you still want to set up security and make sure that they access the pipeline as you want them to access. So we want to be able to also scale up and scale down a bit more freely. So again, not to be constrained to what we have hardware set up. If you want to add a device, if you want to add another machine, you can do that in the cloud a bit more easier. And you can set that up based on who's going to need access and what type of work they're going to do. And I'll go into a few more details of that in a minute. So obviously now we've got faster internet. Well, some of us, depending where we live. But it is there and it's getting better month by month, year on year. And the global infrastructure now we've got in the cloud just allows us to do more in the cloud that we didn't do before. We want to now be able to extend our studios out to where our workers are, who want to remain where they want to be. And also, as I said, if you want to hire someone, you don't have to put that extra burden on them to say they have to relocate. So now you can go to them rather than them come to you, and you still get their talent to come and work for you. And then we can get them to access our development pipeline wherever they're going to be in the world. So what I'm going to do to explain a bit more in detail of what's being done in the cloud today, I'm going to break down the development pipeline or the production pipeline, depending on how you want to call it, into 3 buckets. So I'm going to look at the content pipeline, the build pipeline, and the test pipeline. Now, as we all know, they're all connected. You know, one thing influences the other, and they're not individual pipelines, although they are in a way, but they form up the whole dev pipeline. But what I wanted to do is just use those blocks just to highlight different use cases in each area that we might relate to a bit better rather than talk about them in the whole pipeline context. And of course, different people doing different types of work in those areas access our pipelines in different ways. But underlying the infrastructure should and always be connected to make a good streamlined process. So, what I'm going to do is focus on just a few of these core use cases, and then just explain a bit more about how those, or you'll see how those will transcend up and down the whole dev process, upstream and downstream. So today we're going to look at workstations. Of course, everybody needs a workstation, regardless of what you're doing, whether in the studio or not, you need a workstation. I'm going to look at some examples of version control, which arguably does span the whole pipeline, but for this instance, I'll just talk about it a bit in the context of content and build. Then we've got CI/CD. Again, you could argue it transcends the whole pipeline, but more for build and testing processes. Build farm, which is obviously linked to CI/CD, and then obviously data and security. Our data just spans our whole pipeline. It needs to be there and accessible all the time, and it needs to be secure, right? You know, it's something that we rely on. So, first thing, so workstations. So they're our primary input, right? That gets us into our development pipelines. They're our access points. So we have to provision, install, maintain with everything we need to do our work. Now that installation, that maintenance, the shipping, and the other things that we relate to with a piece of hardware can be expensive, right? Now, when you create a virtual workstation, essentially you're just mirroring what you have on a workstation, but it's in the cloud. But what it means is you can replicate that a lot quicker and easier and get it to the people who need it a lot quicker and easier. So you could do things like work hybrid, where if you're in the studio with your physical hardware, but when you go home, why do you need to replicate the hardware you've got in the studio just to work at home when you're part-time? So you can use a virtual workstation that's got everything set up, same OS, et cetera, and all the tools that you need. So whether you're an artist, developer, a designer, or someone else doing something in the dev pipeline, you're set up to do that work. So virtual workstations allow us just to become that bit more flexible, and we can adapt obviously more quickly to change. You know, when we're going to onboard someone, new hire, for example, who is, well, you just can't ship a piece of hardware to them and provision it with your security you want, with the data you want, when they're hundreds, thousands of miles away, but you want them on your project. So the other thing, obviously, we talked about, we want to be connected to our version control system, very important, obviously, when you're collaborating with lots of users on the same project. You want to make sure that you're all using the same and most up-to-date file, that the check-in and check-out process that you're doing on your assets is synchronized quickly. You don't want to wait. You don't want to just transfer assets. You know, I've witnessed and talked to customers and studios over the last couple of years who are physically sending assets from one studio location to another and are just waiting. And it's a lot of downtime, right? You need to be able to sync if you like you're in studio. So as I said earlier, you know, infrastructure into the studio service can be a bottleneck, and we don't really realize it, but it's what we've been used to because we think it's safe and secure and we can see it. But there's no reason to think like that anymore in the cloud, really. There's so much security that we can do now in the cloud, and we are in control as users as well. So hosting our version control on something like AWS enables you to take advantage of the global infrastructure of the cloud. So not just where you are in a particular region or a particular country. So we can build a series of pipelines, not just for version control. It could span, as we showed earlier, the whole content create, build, and test pipeline. And you wouldn't notice any differences if it was in the studio. We can use things like proxy servers, which essentially are putting the version control servers nearer to where the users are in their physical geographical locations. So you connect in, or they will connect in, just like they were connected into the main server, and they would see no difference. So that's particularly good, obviously, when you've got developers who are all over the world. They're, as I said, creating essentially a single main server. And you can provision those in those locations that are nearest to them. Next, so CI/CD. So another part, a critical part of the pipeline we want to also be connected to straight away. So whether you're using something like TeamCity, Jenkins, or any other continuous integration tools, they can also benefit greatly from running in the cloud. So one of the things there is you can use your build agents to distribute the pipeline or the CI/CD process across different cloud machines at scale when you want to, or you can just schedule parts of that CI/CD process to particular compute instances or machines. For example, you could be now just adding a Mac instance when you need it to do some testing on or to push through, or a fleet of Mac instances. And as we know, again, once you start talking about that particular hardware that you've traditionally had in your studio, it's difficult to scale without going out physically buying more and more. Even harder to then say, actually, I don't want it, it's now gathering dust. So you can't scale down so easily. So that's obviously a big benefit of using the scale of the cloud. So as I said, we're not constrained to what we have in the studio, and we can scale when we want to and as we need to, and obviously give access to people when they need to as well. So build farms, I don't know about some of you, but build farms has always been completely a bottleneck, and it's always at capacity, and everybody wants to access it. And if you think, and this is why obviously I gave you the background of where I came from. So throughout my life, whether it's been doing a render or a particular physics calculation or all these things, I go, why am I waiting? Why do I have to wait? So build farms to me is like, you know, it's the main thing to say we should be able to extend when we want to. But we'll also treat the build farm predominantly for doing one thing, and that is obviously it's part of the CI/CD process, and it's pushing through our dailies. So we've always got an up-to-date build to review at the end of the day or the next day, have publishers access. They can do checks on that, and we've got different branches going through there. It can be very complex, and therefore that's a reason why it does just grow in size. Plus the fact, as we said earlier as well, data gets bigger, the amount gets bigger, and it always increases, and everybody after their project goes, okay, how much and by what do we need to extend our build farm for the next project? So it's always an ongoing thing. So whether you're building across PC, console, or mobile, I was talked about Mac instances earlier on, Windows and Mac, you want to be able to just use extra resource when you want it. And that, again, is whether you're sitting at your desk and you just want to tap into some extra power. Why do you have to wait for a job to go through on the build farm that might be provisioned for something else? Quite important, obviously, but why can't you access it as an individual user and just use it for a few minutes and accelerate what you're doing locally on your machine? There's these untapped things we haven't, haven't yet done as day-to-day in the games industry, but I'm sure that these will start to happen. So accelerate asset creation, shader compilation, rendering, well, we talked about, but unit testing, code analysis, builds, packaging, obviously things, but there's a whole host of other use cases that we can use extra compute for that I'm sure that we'll be doing very, very soon. Finally, our build farm needs to be connected to, of course, where our assets are. And again, these need to be secure, but in the cloud, we can make them scalable. We can obviously extend them to people wherever they may be working. We can replicate them. We can make sure they're monitored for any malicious or unauthorized access. So again, the cloud gives you a lot of flexibility here. And studios of all sizes are using this AWS storage and protecting their data as they work. I'm conscious of time, Chris, aren't I? So finally, what I'm going to run through is just some examples of what's being done on AWS today. So this first one is just an example of a hybrid setup version control. So what we've done here is set up an environment to make sure that whether you're located in the studio or you want to work on a virtual workstation and connect into the infrastructure, or you want to work on your local rig, whether that's at home or another location, then you can do it. So what we've tried to do is look at examples in different ways. And then depending on what your use case is, we can easily adapt them to how your workers are or where they are and how they want to access the development pipeline. This is another example. In this case, it's a Jenkins CI/CD pipeline, but we've included the version control system set up in there as well, and the ability to scale across multiple instances or cloud compute power in different locations. Again, whether you're working remote or in a studio environment. So we've got other examples that show you how you can set up a Unity build pipeline, or we've got engine agnostic ones that cover cross-platform development, of course, and we've mentioned including Mac OS as well. Then finally, we don't have time to show you this live today, which is really unfortunate because obviously I'd say it's a great demo because it is. But we do a live demo essentially where we set up a virtual workstation, and on it we will run the Unreal Engine and essentially work as you would normally do on something graphically intensive like the Unreal Engine. Create assets, edit assets, move around using the game controller as if that was a local workstation. And then obviously we encourage you to test that versus your local rig, and hopefully you'll go, yep, there's no difference. Then in the demo, we also go on to show Perforce control, the version control system, and explain how we're connected to it and where we are physically located. In other words, where are we running the virtual workstation from, and how's that connected into the infrastructure, and then perform some check-in, check-out process just to show that it's working live, and everything as it would do if you were running local in the studio. Then we'll also run through an Unreal Swarm example where we will generate what usually is a very time-consuming light mass render on a local machine that typically takes about an hour to do in the scene we use, and we'll reduce that down to about 4 minutes by distributing that out to a load of compute instances in the cloud and just showing how quick that could be. Now, normally that's a process that you would do as part of your CI/CD pipeline, but sometimes you want to go and test something while you're sat there and you'll just wait. We shouldn't have to do that. And if it costs you a few dollars or less than that, why not? Just go, let's burst out and come back. So there's loads of these examples, as I said, we can start to look at and perform in real time. And then finally, we will do a complete Unreal Engine or engine code build using Incredibuild. And again, it's something that normally takes a good 2 to 3 hours if you were going to sit there as a programmer and do it live, or sorry, do it on your local machine. It will take 2 or 3 hours, and again, we can reduce it down to about 15 minutes with a certain setup in the demonstration. So, most happy to kind of set up those sort of demos for anybody that's interested. AWS team are here, they're all branded up. We've got some great, fantastic solution architects as well that are here. If you've got any technical questions, they can answer. So please drop by. There's a stand, obviously on the stand and so forth there. As I said, they're branded, you'll see them. So thank you. Hopefully, Chris, I didn't go over time.
That's all right, a little bit.
Oh, I thought we might have done. Sorry.
That's okay.
Very much.
No, thank you so much indeed. That's fine. That's really good.
Well,
That's so far above my head that I don't even have any creative questions. I don't know if anybody has a particular question. If we have time for one, I think you've blinded us with science there. But as only.
More importantly, I just hope everybody understood it. I was going to open by saying, when you haven't done a talk in 2 years face to face, because normally you're hidden behind your computer and you can just kind of do things verbatim.
No, it's different. You were very good. It's AWS are here, so if you've got, do check them out. You've got a booth upstairs, is that right?
Yes.
Yeah, check the booth upstairs, and you can answer. They can answer good questions in a way that I certainly won't be able to.
I'm sorry.
All right.
Sorry for going over.
No, don't worry. We're into the final session.